Hello and welcome to Future Construct. I'm Mark Oden, the CEO of BIM Designs Inc. We have a special episode today at Geo Week 2023 in Denver, Colorado. I'd love to introduce our first guest of the week, Kourosh Langari, project engineer with Caltrans. Kourosh, I'd love to hear about your position with Caltrans. I'd love to hear about your history, how you got into Caltrans. Let's start there. How did you end up at Caltrans?
Again, thank you for having me. Yes, I actually went to school in Oklahoma State University and University of Oklahoma in the 80s. And then I went to Berkeley, I think back in '84, and I fell in love with Bay Area. So when I got a job offer from Caltrans to go to Northern California, I chose that back then. And I started working in Caltrans back in '87. And in 2008, I went to private sector and worked for URS and AECOM. And now I'm back at Caltrans, finishing my tenure. I'm working as a project engineer, delivering infrastructure projects for a variety of projects in San Francisco Bay Area.
Wonderful. Yeah, what an amazing career that you've had, especially to be working with Caltrans and to have the transition of public and private sector.
Sure.
That's incredible. Yeah. And I too love the Bay Area, so yeah, that's just a fantastic place. Would love to hear, in your experience with Caltrans, just to put things into scale or scope for our listeners. How big is Caltrans? How many miles of coverage, and maybe budget size? Just topics to help understand the size of Caltrans.
California Department of Transportation is one of the largest DOT in the nation. We roughly have up to 17 to 18,000 employees across 12 different districts. And the beauty of California Department of Transportation is we sort of handle all sort of terrain. We got from really high altitude, in Northern California, in Redding and Tahoe, and then we got, in Fresno, we got, plains, and then we got metropolitan areas. So it's a really nice sandbox for a project engineer to be able to handle different type of projects with different type of topologies. So it's really exciting.
Very cool. And so speaking of the different topologies and the different climates, here at Geo Week, it's a big focus on LIDAR and topology scanning and BIM. How does Caltrans integrate technology into the performance of their service?
Yes, California Department of Transportation, we also partner with FHWA and AASHTO, which are national organization. And as a matter of fact, all the 50 DOTs, we sort of have a partnership that we're always looking forward for new innovation to bring efficiencies to our workflow, and so we can spend taxpayers' money more efficiently and deliver better service to our commuters. So innovation is one of the pillars of our organization, and we actually have a division of research that's set up in headquarters. And we go out there and we have annual conferences, and we also partner with UC System, University of California, and California State Universities. Do a lot of research with Fresno State, UC Davis, UC Berkeley, transportation centers. So again, we're always looking forward, bringing new ideas and changing our workflow.
Wonderful. And you have a presentation here at Geo Week this year. What's your presentation?
I do. We have a presentation on Tuesday. It's BIM for Infrastructure and Common Data Environment. And we essentially brought a panel of private sector consultants and software vendors together to sort of discuss the digital ecosystem to allow multidiscipline engineering projects be sort of using the same ecosystem, digital ecosystem, in a common data environment. With big software companies like ESRI, Bentley, Autodesk, and Trimble. So that's the sort of the tip of the spear for this technology moving forward for the next couple of years.
So you're working very closely on the exportability of the data and the portability of that data.
Exactly, and one of the challenges that was facing our industry was that for past 20 years or so, we've been sort of dealing with data exchange file formats. So every time you transfer these or translate these data sets, you lose data. So the whole idea is to start establishing common data environments and common data formats that all the different vendors can plug into. So for past 5 years or so, we've been sort of delivering our digital data to the construction using land XML file format, but we're starting to transition to IFC file format, IFC 2.3, and pretty soon I think the schema for IFC 4.3 will come out and we're going to transition to that. And the beauty of the IFC format is there's no data loss, so you can get all the detail that you put together during the design, and you can pass it along to the construction. So this way you have a lot more efficient construction phase, and you can eliminate a lot of the potential contract change orders or requests for information during the construction.
Well, thank you for your leadership there. The industry needs leadership in requesting that common portability of data, and
Yes.
so it's wonderful that Caltrans and California DOT is behind that. What do you see as some of the major challenges for Caltrans in the next few years?
Yeah, and again, these challenges challenging our industry, not just focused on Caltrans, I think across the board, both private sector and public sector. Some of the challenges going to be making sure that there is enough expertise in the project units that are delivering these projects to understand all the intricacies that goes with delivering these type of projects. So the project engineer's role, if you take a look at the legacy to now, is sort of changing, because now everything's data driven. So a project engineer should have the ability to understand some IT, some of the database requirements, understanding networking, understanding how to manage the data, so some of the digital administrative tools that's required for the project engineers. So I think that's one of the challenges, making sure the expertise out there. The second thing is, as I said, trying to eliminate those data exchange file formats and to go to a more binary file format so we have no data loss. And again, obviously, funding to make sure that as you go forward, there's enough resources available, because when you shift from legacy to BIM for infrastructure, initially you have to spend more resources to deliver that 3D parametric model. But when you have that model, any subsequent change is going to be much more efficient.
Mm-hmm.
So just understanding that resource balancing moving forward, I think that's one of the key challenges.
Yeah, that's a really great point about how if you have the model, it will help in the future, and it'll help reduce costs in the future, even though there's an upfront investment. I think it's incredible that Caltrans sees that. How do you convey the ROI, whether it be internally to Caltrans or to larger organizations? How do you help organizations see the ROI behind it?
Yeah, so return on investment, that's a key issue, because that's one of those things that you have to go to the management and actually make a case that using this new workflow, you're actually going to have a good ROI. And right now, we're actually taking a page from the European community, because the European community, they legislated about 5-10 years ago, adopting BIM for infrastructure. So if you take a look at some of the projects, mega projects that's been delivered in Europe, they usually have a 20 to 25% less resources required using this new format. So nationally in the US, this BIM for horizontal infrastructure is still picking up. So we can rely on some of the study that was done in Europe. At the same time, we're starting to look at some of our own requirements, because again, US picture is a little more complicated, because you've got 50 DOTs and slightly different type of standards, and also understanding the requirements for digital twin and as-built moving forward, and making sure that we also align with the federal requirements. So we're still working on some of the detail to making sure there's appropriate legislation, being served across all the 50 states, so we can make this sort of a mainstream industry moving forward.
Wonderful. Looking to the future and wrapping up a little, some of the technologies you've been learning about in the past few months, and certainly here at GeoWeek that you will be learning about, how do you see, which technologies do you see Caltrans most interested in?
Yeah, so some of the technology that's key for us is the traditional approach to developing digital terrain model was that you use one software and you produce one method, and that's your DTM. Moving forward, you're going to see a lot more fusion or mashing of DTM that's coming from different data collection methods. So for example, more and more you can see that we're starting to combine conventional survey with mobile terrestrial scanning, with stationary scanning, unmanned aerial system, and we're mashing it all together and producing one combined model. And by doing that, you're optimizing the surveying costs, and you're also optimizing the model that you're putting together. And also moving forward for the new design, we're starting to adopt ISO 19650 standards, which was developed at Penn State and also worked on at Stanford University. And ISO 19650 standard allows you to establish a project information model and then move that model across various phases of the project as you get into the asset information model, which is the last phase, and you actually produce the digital as-built. So moving forward, I think those are the key areas in future, at least in the next 2 to 3 years, that we'll be concentrating on and looking at it.
And you mentioned the as-built, which is just as important as the model itself. So how is Caltrans investing in the as-built?
Yeah, so the as-built industry, I mean, traditionally, when the construction was done, the resident engineer used to redline, the plans, and then the plans came back to the CAD office, and they went back and did the digital as-built, and that process usually took a year to a year and a half. Now, moving forward, the digital twin is sort of, the goal is to develop that within a couple of months after the facility is built, and usually the onus is going to be both on the contractor and on the owner to, as soon as the roadway or the bridge is built, that you go out there and start scanning it, and then you start doing some extraction of some of the key features and into vector data, and then start adding additional attributes such as asset-related attributes such as the quality of the member, who put it together, the date, some of the other attributes that goes into the Federal Highway Administration requirements. So again, the specification and the standard for digital as-built, it's sort of being written right now by the industry. So hopefully we can solidify some of those standards in next 6 to 12 months and start looking at some proof of concept.
Oh, that'd be amazing.
Yes.
Well, I love the care that you bring to standardization, the care that you bring to Caltrans, and the care that Caltrans has in adopting technology. I think it's incredible. I'm proud to be with you today, and thank you so much, Kourosh, for your time. And good luck at your presentation.
Thank you very much.
Yes,
Looking
sir.
forward to it.
Thank you. Hello and welcome to Future Construct. I'm Mark Oden, the CEO of BIM Designs Incorporated, and we're here at Geo Week 2023 in Denver, Colorado. I'm here with Douglas Dunrud, Vice President and Technical Principal at WSP USA. Thank you and welcome to the podcast.
Yeah, thank you.
Douglas, I'd love to start with where did your career start and how did you end up navigating to WSP and becoming Vice President there?
Well, I graduated in 1987 from Colorado State University. So I started my career with Caltrans, and I worked my way up to a branch chief in structures design. So yeah, a 30-year career with Caltrans. I did a lot of different things, including some building design and structure construction, which was fun. And then I was in charge of a design branch, for the last 10 years of my career with Caltrans. So I led a team of about 13 engineers and detailers, designing and producing plans and quantities for various projects. So it was really interesting. But my kind of secret or my passion was for using BIM to deliver projects more effectively, basically. So in 2018, I joined WSP. I retired from Caltrans after 30 years and then joined WSP, which is an engineering consultant, one of the biggest in the world. And yeah, I've been doing BIM for infrastructures basically for the last 5 years with WSP. The last couple of years I've been working on a huge project on I-5 between Oregon and Washington. It's called the Interstate Bridge Replacement Project. So it's about $6 billion project. It's huge.
That is. Yeah.
And yeah, they'll be up to, more 40 to 50 bridges on that project. So
that's incredible.
Yeah, and the nice thing is that it requires the delivery of a digital twin. So we're doing everything on this project model-centric, which is the way I've been wanting to do it for the last dozen years.
Yeah.
So instead of producing like CAD drawings or independent bridge analysis, we're doing everything based on 3D models. And we're tying everything into the geospatial, we have a LIDAR scan for the whole project. So we're tying everything in. So it's actually the way, in my opinion, projects should be done.
Sure. That's an amazing story, and I mean, to implement, it sounds like you were a huge adopter of BIM or bringing in BIM into Caltrans, you and your team, and now you're able to expand that above and beyond the scope of Caltrans to the world of WSP and world of infrastructure.
Yeah, I think, DOTs are kind of bureaucracies, so they move a little slower. With WSP, I've really experienced being able to move a lot more quickly.
That's beautiful. So, so can you dive into some of the use cases, especially how you're using the modeling component of BIM into this? You said it's 30 bridges?
Well, over 40,
over
close
40.
Maybe 50 or more bridges.
Oh wow, incredible.
Yeah.
And this conference, especially at GeoWeek, we're focused on BIM and GIS, and so it sounds like you're using both of those components to model out this entire infrastructure.
Yeah.
That's incredible, and you have a lot of, from what I understand, you have a lot of experience in working with the tool providers like Bentley and CAD.
Yeah.
So could you share a little bit about your experience and how you help influence the tools and technologies that the market sees?
Yeah, so when I was with Caltrans, Caltrans was using Civil 3D as its roadway design software. And, my group kind of specialized in using that the way I thought it should be. Now with WSP, we're really kind of flexible. Whatever the client uses, we use. So for that interstate bridge replacement, I'll just say IBR, we're using Bentley. So we're using their open road software, and we're using ProjectWise to manage all the files. So really we have a repository where all the files reside, and everything is geospatially located. So we have the survey data, we have the all the utilities, the roadways. So I'm building the bridges in the same environment as everything else.
And what are some of the major challenges that you're facing in building them in this virtual environment?
Well, that's kind of a political thing. It's really the decision makers. They haven't honed in on a solution. So we can't really go ahead of the political decisions that need to be made. Like, for instance, how many lanes? We're still after 2 years of working on it, we still haven't decided on exactly how many lanes there's going to be.
And does the technology that you're implementing help the decision makers in that decision process? So maybe through simulations, perhaps?
Well, a lot of it is visualizations, right, and cost estimates. So it always seems like that's, some kind of allow people to kind of experience in advance what it's going to be like to, have a new structure there.
Right.
And then what is the cost associated with that? So the big thing, and that's why I'm really glad we're doing it this way, is you want to model everything what we call parametrically. It has parameters. Like a bridge width is a parameter. So we want to be able to modify those very quickly and easily rather than going back to the drawing board and starting all over.
Right. So, so there may be, for the DOT, there may be an upfront cost of understanding the visualization of this, but long term, there's the potential of saving them, of making the wrong lane number choice, or installing in the wrong location or vicinity. Is that right? You're helping them sort of understand all the possible outcomes before construction starts?
I think it's kind of an education process. We're kind of educating them all the way through. So it is a little bit more upfront cost, you might say, to model everything. And we're dealing with that even on cost estimates now. Because we've modeled everything, we can get all the costs from the models. And it might have taken more than just doing a spreadsheet on the first rounds. But when you get into the more detailed estimates, our models will provide all of that. And we can divide it up into the different contracts that they're going to be doing. So, yeah, I think, everyone's starting to see the advantages of doing things on model-based workflows.
That's fantastic, and I love to see that in your career. You've been so influential, and you've been understanding and digesting them, but also influential in them. And then here is, like you said, this is an ultimate project with 50 plus bridges, big civil project, to be able to do it how it should be done. So I'd love to see if that, if that starts to influence standards or starts to influence the community, the construction community in any way to look at this as a great case study.
Yeah.
So moving on to speaking a little bit about Bentley and sort of the agnostic approach that WSP is taking to software, because you're choosing it based on what the clients want, and it's very relatable for our company as well. So I'm curious, how do you approach the training component when you're moving from let's say Civil 3D to Bentley, for example?
Yeah, so I mean, training is actually, part of my presentation this morning was on training, because the first question on training is, who pays for the training?
Right.
So if it's a big project, like on the IBR, we did the training on some of the Bentley products as part of the contract.
Mm-hmm.
But if it's a smaller contract, you have to basically do that on overhead, the training.
Mm-hmm.
The other thing that's kind of a challenge is, the whole thing of use it or lose it, right? You could get trained, but if you don't use it for a year, how well are you going to be able to use it in a year?
Right.
So we're kind of focused on having the training that you need right when you need it, like right in time training, and then also have a repository of all those trainings.
Mm-hmm.
So I think we've done that with all the Bentley trainings that we have. We've recorded them all, and they're all available to everyone on the team.
Also from a technology side, I've always been impressed that Bentley has an open approach. Have you seen an impact in your project compared to CAD, seeing Bentley have an open API access or open software access? Has your team adopted and used that?
Yeah, I mean, we're trying to do everything open, and we're not using only Bentley products, and I'm actually pretty impressed that Bentley is not like fighting us when we're using some other software. We're using some Autodesk software, we're using open source programs, and we're storing everything on ProjectWise. So I think there is that idea that everybody knows not everything in the world is going to be designed using their software. Pieces are going to come from different directions, right? And we have to be able to fit them all together. And that's part of what I like about this week is if you geospatially position everything correctly, it doesn't really matter how it was created, right? It all fits together, just like things in the real world fit together.
Yeah, I've spoken with a few guests about how important location is, and it sounds like you're bringing location into this project as well.
Yeah, that's one of my and ask anyone. That's one of my pet peeves. Is a lot of times bridges are separated from the geospatial realm. So a lot of the team members will work in the same geospatial space, but bridges kind of do their own thing. But that's one thing I don't feel like we should do as a bridge industry, infrastructure. It needs to reside in that same space. And it's even you look at things on Google Earth, you should be able to see your structure in Google Earth in the context of the site.
Right. Very cool. So you had mentioned your presentation at GeoWeek this week. Could you tell us a little bit about what that presentation was and some key takeaways?
Yeah, so my friend from Caltrans, Kourosh Langari, he invited me to present the bridge side. So we did the whole BIM for infrastructure, and I represented the bridge side. So I really worked like a subset of the whole roadway infrastructure. But yeah, I'm a strong proponent of doing everything model based. And of course, those models are geospatially located. So, and then I'm kind of pushing the envelope of using the bridge models further downstream for construction, fabrication, and then I think a huge thing is going to be the asset management models. I mean, a bridge gets built, but it's around for 100 years. And, right now you have paper as-builts. They're stored electronically, but they're paper as-built. So it's just like reading a plan 100 years ago. But now we should have, alongside, I'm not saying get rid of paper as-builts, but alongside of that, have a model that, future people that touch that project, maybe widen that bridge or whatever, they have access to that model. And inspectors, if they, are inspecting the concrete or the girders, they can attribute those comments to his geospatial location on the model.
Mm-hmm.
You don't have to look in the index, where to find that comment.
Mhm.
It's tagged. It should be tagged to the model.
Right. That's wonderful. And what other takeaways do you have from GeoWeek this week?
Well, it's just, this is my first time here. I've never been here, and then I come and speak. But I'm pretty impressed. A lot of people are super passionate. And you go to the expo, and you see drones all over the place.
Right.
So there's a lot of cool stuff here.
Yeah, it's amazing technology between the scanning and the drones and the aerial. It's really cool.
Yeah.
Well, thanks for some insights into your background and some insights into your philosophies. I'm really excited to see how this project that you're working on continues, and I would really love to see that as a case study at maybe a future GeoWeek conference.
Yeah, I would love to. Right now, everything's confidential, so I can't share anything. But I'm sure, if not next year, the year after, I think we'll be able to share everything.
Cool. I look forward to it. Thank you, Douglas, so much.
Of course, thank you.